Hello everybody, welcome to the 8th video of module 3, and here we are going to add one final method to this rocket class that's going to help us calculate the distance between two rockets which are actually the instances of that same class. And over here the distance we are going to measure is with respect to this Euclidean distance, and once this method is created we are also going to test it. So let's get started. Alright guys, so now you are in that position where you can go ahead and manipulate this rocket class the way you want. You can have bunch of more properties over here. For example, what is the color that you want to give to this rocket? What is the type of this rocket? What type of fuel it works on? A lot of different attributes that you can give over here. At the same time, you can also give a lot of different behaviors also in terms of these methods. For example, one of the methods that I'm trying to add over here is to calculate the distance between two rockets. For example, let's say over here we are having this rocket 2 and this rocket 3. So at this given location, what is the distance between them? If this is something that I want to do, I can surely do it, and I'm just going to demonstrate that right now. I'm going to copy this code and create a text cell with a heading. Add another method to the rocket class that calculates the distance between rockets. Between two rockets. Let me be a bit specific over here. How can I do this? I just need to paste this code first of all and create one more method. That's it. And let me call it as get distance. Okay. Now see, you need to understand what's really happening. Let me have this kind of space where I'm going to have two different rockets. Let's say one rocket is over here. Okay. And the other rocket is, let's say, maybe over here. Now, how can I get this distance between them? The straight, or I should say minimum distance between them. I can do this with the help of Pythagoras theorem. How? I'll just calculate what is the difference between their x coordinates. Because I know that both of these rockets are created from the same method, I can have this excess of this x and y, current location of the x and y, right? Of that particular rocket, I mean. So if I'm having the x and y of this rocket and also of this rocket, I can find the difference in the x and also the difference between y. So that difference between y will be a bit difficult to show you all over here. But yeah, this is something that I'm trying to do. Okay, I'm just going to copy this. Just going to come over here. I'll do one thing. I'll just copy this whole thing and paste it over here. Okay, so it's done in a faster way. Yes. So if I'm having the difference in the y location and the difference in the x location, I can simply go ahead and use the Pythagoras theorem where I'm going to square the difference of this x and the difference of this y, add them together and take the square root. That's the Pythagoras theorem, right? And through which I can get this shortest distance between these two rockets. And this is called as Euclidean distance, if you don't know. Okay. So this is something that I want to achieve. So what do I need? I need the x and y value of this rocket and the x and y values of this rocket. So how can I get them? It's pretty much simple, right? I just need to have I need to think of a way through which I can access both of these rockets inside this class. So one rocket access I am already having with the help of the self keyword. This self keyword is the current rocket that I'm dealing with. For example, let's say if I want to calculate what is the distance of this rocket with respect to this rocket. So this will become my current rocket. This is some other rocket that I have created from that same class rocket. So I'm going to pass in two different things. First is the self, to get access to the x and y of that self, and the other one would be the other rocket. And in this other rocket, I'm going to pass a whole rocket, and from that rocket, I'm going to extract this x and y values of it. How? Let's try to figure it out. So yes, this is the get distance method. And what I'm going to do, I'm going to first of all calculate the difference between x. Okay, so let me just call it as x div. What is x div? It's simply the difference between self.x and also the other rocket.x. Remember this other rocket, if I want to get access of that x, and if there was a object called as other rocket, if I want to get its x location, what I do? I just call the name of that rocket and do .x. That's how I get the x value of that particular rocket. And that's exactly what I'm going to do. What I'm going to do over here is I'm just going to create this kind of a brackets. To be honest, it's not really required. I'll do self.x minus other rocket.x. Just like this, I'm going to create y difference it's self.y minus other rocket.y. Now you might be asking me like, why we are not doing the other way around. Other rocket.x minus self.x, or maybe other rocket.y minus self.y. Even that is fine, because at the end of the day, we are going to square it up, right? So the difference in the sign is not going to matter. Even if it's negative or positive, it's going to get squared at the end. And now I'm going to find out the distance. And what is the distance? It's the square root. So how do I get excess of that square root? There are a lot of ways I can do this. One of the way that I can do is to raise a power of half. That's the square root, right? Anything to the power of half is called square root of that particular thing. So let me do this. First of all, I want to square x difference and y difference. So x difference, with the help of these two asterisks, I'm saying that x difference is getting squared. Similarly, I want to do y difference square. Okay. You don't really need to have a space over here. It's completely fine. You cannot have a space. Even that is fine. With the space is also fine. And after this, whatever is the output of that, I want to take under root of it. I can just take a power of this to 0.5. That is half. And this is the distance between my two rockets. Okay, the current rocket and the other rocket. And the return of this is what? Distance. It's going to give you the distance as an output. I can also, let's say for example, round it correct to 3 decimal places by using this round method that we are having in Python by default. So I'm going to pass that I want to round this distance correct to 3 decimal places. That's it. I'm going to run this code. I'll also add a comment over here. Calculate Euclidean, I'm not sure about the spelling. I hope it's correct. Calculate Euclidean distance between two rockets. That's it. So yes, I guess everything is done. I'll just rerun it. And now what I'm going to do is I'm going to again, let's say I'm just going to create two more rockets. That is rocket 4 and rocket 5 maybe. Let's say rocket 4 is going to be created by how? Let me call it as again minus 10, 0. And the other one is rocket 5. It is currently present at rocket 10, 0. So what is the difference between them? It's 20, right? If there is an origin in between, so minus 10 to origin is 10 units. Then from origin to 10, it's another 10. Or let me just keep it 0, 0 as of now. Okay. And let me just print the coordinates also. Print rocket 4.x, rocket 4.y. And I'll just do it with the help of my format strings. And within the curly braces, I'll be giving this inputs as always. And I'll also repeat this for 5. Okay. So it should be minus 10, 0 and 0, 0. Yes, that's correct. Now, instantly we can see that the distance between them is 10 units. Let's just testify it with the help of this get distance functionality. So now what I want to do is I want to find out distance of rocket 4 from or with respect to rocket 5. So rocket 5 is the self and rocket 4 is the other rocket. Okay, so this is something that I want to do. So self, you give first rocket 5, and on that rocket 5, I want to use that get distance with respect to that rocket 4. Rocket 4 is the other rocket. Rocket 5 is that self one, the current object, right? So if I go ahead and just, let's say, store it somewhere, distance is equal to this, let's say, or maybe just let me write it as distance underscore 4, 5. So what is the distance between 4, 5 maybe? And then I'm going to print the value. I'll also again use my f string. That's going to say that the distance between rocket 4 and rocket 5, or let me be a bit more specific. The distance between rocket 4 with respect to rocket 5 is what? Distance 4, 5. And this is correct to 3 decimal places, right? This is something that I'm writing. Let's see if I'm getting 10 or not over here. We can clearly see that the output is 10. So this is something that we are looking forward to. Now, again, what I'm going to do is I'm just going to call this rockets. I'm just going to copy this whole code over here for rocket 2 and rocket 3, or else it will be very much I will be just mixing up the code cells, and it might create some kind of errors for you a bit later on, because all of them are getting stored at a particular memory, right? So I don't want to change them. Let me create, or let me just move this rocket 4 and 5, okay, because we are having that move functionality as well. Let me do that. Move rocket 4 to the position. Let's say, for example, currently it is at -10,0. So let me fly it up to, let's say, for example, -10 is going to, let's say, -15, and that y distance is going to go up to, let's say, for example, let's say 10. Okay, just coming up with some random numbers. So rocket 4, I'm going to make it move. I want it to move to the left by 5 units, so -5 in x, and in the y direction, let's say I'm going to move it up with some kind of speed so that it's going to get to the 10. Okay, so this is the location that it's going to reach. After this, I'm also going to move rocket 5, which is currently at 0,0, to, let's say, maybe let's say x is not changing, but y is changing to 15. Okay, so over here what I need to do, I just need to say rocket 5 dot move rocket. Because x is not changing, that's going to stay 0. My y is changing, I'm incrementing it by 15 units, so it's going to be 15 over here. So I guess that's pretty much about the rocket 4 and rocket 5. And after this I can again print my, like, this thing, copy this and paste it over here. Get the new locations of rocket 4 and rocket 5. So these are the new locations, guys, -15 and 10, and 0 and 15. Everything is working fine. And now the time has come to test this distance. I'm just going to copy this whole code again. Okay. What is that new distance? New distance. New distance. I'm going to run this code. Clearly we can see that we got the answer correct with the 3 decimal places, and it's 15.811. You can literally verify this if you want. Okay, I'm going to have a difference between this -15 and 0 is -15, right? So -15 is going to be squared, plus what is 10 minus 15? It's again 5. So what is 5 square? I'm going to take root of this, and if I check the answer, okay, it's giving me some kind of an error. Okay, it might be because of this kind of brackets that I need to put over here, and then if I do this 0.5 over here, it should be fine. It's giving me 15.811. This is something that we really expected to give. So yes, guys, that's about how you can create a lot of different things with just one class that you are creating over here. That's the power of object-oriented programming. I hope you have now understood this concept. Alright guys, so that's the end of the video over here. I hope that you were able to understand almost all the concept that was demonstrated over here. Now in the next video, I'm going to show you that how you can download this file into your system and then finally add it to your GitHub repository. So I'll see you in that video.